yo, this is Coach Ray. Next lesson's up. We're talking about graphs of rationals. This is the last lesson in the rationals unit. So up next will be our test. Let's get started. Okay, rational. I've said this at the beginning of every video, but a rational is a fraction. Specifically, it's a fraction that has a polynomial on top and a polynomial on the bottom. Okay, so if you look at example 1, this is a basic one. The numerator is just a constant. That is a monomial. All right, the denominator is a binomial. So this is a rational. And in my class, don't forget, I'm not so much caught up on you being able to take a pencil and plot points on a coordinate grid. Okay, we have tools that will do that for us. The state of Arizona has even said that I should teach you to use your technology wisely and efficiently. So I want you to use Desmos when it comes to graphing. And then understand all the parts of this graph and be able to identify stuff. So your test will be like this. You'll have access to Desmos, so you can plug the equation in, look at the graph, and then just answer questions about it. And that'll be what your assignment's like too. All right, the only new thing that you might not know up on the board right now is this. This word right here, asymptote. That is pronounced asymptote. Asymptote.
How old are you?
So that's what that word is. So in asymptote, I would define as this. I really picture it as like on a graph, this invisible barrier, and I just visualize like an invisible like electric fence, right? So the reason it's like an electric fence is our function, meaning our graph, these blue curves here, our function can get closer and closer to that electric fence, but can never touch it because it'd be electrocuted. Okay? So forever it will get closer and closer and closer to that barrier, but it'll never actually touch it. And the reason that's possible is because of decimals. So if you get closer and closer, you can be 0.1 away from it, and then 0.01 away from it, and then 0.0001 away from it. So it is possible, because decimals are infinite, that you can get closer and closer and never actually touch it. Okay? So you can identify asymptotes just by looking at the graph. I see two. We'll start with the vertical asymptote. Okay, vertical asymptote, vertical is up and down. So there is a vertical barrier here where our function is getting closer and closer and closer to without actually touching it. When you see it graphed, we usually show asymptotes with a dotted line. Okay, 1 second. All right, so here we go. This red dotted line is how we show a vertical asymptote. When you see it on Alex, they put dotted lines on there as well, so you'll see them do the same thing. And that's just how we show that invisible barrier. Okay, so this particular invisible barrier is at x equals -1. People forget, but vertical and horizontal lines are x equals a number or y equals a number. Okay? Now more specifically, vertical lines are x equals a number. Also, Alex requires you to type in this whole equation. You have to type in x equals -1, which means you have to remember that vertical lines are x equals. Okay? If you forget on the assignment, it'll probably just say something like, "Oh, you put the wrong thing." On the test, if you put y equals, it will mark it wrong. So you're going to want to make sure you know that vertical asymptotes are x equals something. And it's just whatever it's going through. It's going through -1. Everybody okay with that? Let me show you the reason why we have an asymptote here. Okay? If x were -1, which is what I'm saying here, x equals -1. If x were -1 right here, I would have -1 plus 1 in the denominator. -1 plus 1 is 0, and we cannot have 0 in the denominator. Mathematically, we say that it's undefined, but me as a weird teacher, I say that if you have 0 in the denominator, it makes the world blow up. We cannot make the world blow up, so this is why our function curves and gets closer and closer, but never actually touches it, because if it got to x equals -1, we'd have 0 in the denominator and the world would blow up. Okay? So that's kind of where that comes from. All right, there's a horizontal asymptote too. Hopefully you see it. It's just this x-axis. Okay? So in both directions it gets closer and closer, but never actually touches. So how we write that is horizontal lines are y equals, and because it's on the x-axis, it's just at 0. Yeah?
So like if it ever touches it, it'd be like it untrue.
Correct. With rationals, though, we always have asymptotes, so it won't touch. And what you can do is in Desmos, you can plug this in, and you can scroll over to the right as far as you want. You can keep zooming in, and you'll see that as far as you go, it'll never touch. All right, domain and range. This is the thing I'm a little bit more worried about. I'm going to explain it the same way I always do right now. Okay, domain is dealing with x, range is dealing with y. The next question I always ask is, are there infinite points here, or are there a finite number of points? Infinite. It's going forever in a couple different directions. Also, any curve on a graph has infinite points on it. So I don't want to, and every single point has an x and a y coordinate. So domain is asking me every single one of those x's and those coordinates. I would die if I tried to write down infinity x's. I'm not going to do it. Okay? So instead, I'm going to say the domain is from the smallest x to the biggest x, and it includes everything in between. All right, where I find the smallest x is looking to the left. All right, so I ask myself, how far to the left does this go? Forever. Forever to the left is negative infinity. I use a parenthesis because you can never actually get to negative infinity and actually get there and touch it. Okay, so we use a parenthesis. How far to the right does this function go? Positive infinity. It goes forever to the right. However, there is a break in the middle, correct? There's a spot where we will never have a coordinate point where the x is -1. There's no point on that asymptote. Okay, so I need to write it like this. I'm going to go from negative infinity to -1. Am I ever touching -1? No. So that means I need a parenthesis. Okay, here's a symbol we've used before. A U. It means union. Okay, mathematically what it means is and. So I'm going to say the domain is all of this stuff and something else. And Alex is kind of crazy because Alex actually has an option for you to put the word and in between. But it marks it wrong. So that was super weird. So even though it means the same thing, you don't want to use the and symbol. You want to use your union symbol here. Okay? So now I've got to show the part over on the right. Over on the right, it's from -1, but not including it, to positive infinity. So there's two parts to this graph. Because it was broken in the middle there, I've got to say my domain is everything from negative infinity to -1, not including -1, and then everything from -1 to positive infinity. Yeah?
Okay, you know how you said it will never touch -1?
Yes.
Like, it's not touching 0.
It does. The question is, does it ever touch 0? It does right here. One of the points on this line is 0, 3. So if I'm asking to write all of the x's that this function touches, it did touch at 0. Okay, next part. Good question. Range. Too much going on right now. Range is just y's. So I'm going to go to the smallest y up to the biggest y. Smallest y is down. Clearly goes down to negative infinity. It does go up to positive infinity, but there's a break in there. So I need to show that at 0, it doesn't touch, and then it's also from 0 up to positive infinity. Yes?
So basically, you're making a bridge. Like you're putting a bridge between two lines with the U.
Kind of. The U really means and. What are all of the y's in here? It's everything from down there up to 0, and it's everything from 0 up.
So you skip all of this one.
Yeah. Okay, all right. I just want to mention this right now. There's about 4 different ways to write domain and range. There's different forms that you could write it in. I always use interval notation because that's what you're going to use in pre-calculus with Ms. Martinez. All right. Alex uses some different forms every now and then, and whenever that comes up, we should talk about it as a class. But I will tell you that on this assignment, the only thing they use is interval notation. All right. Example 2. Alright, example 2. It's graphed here for you on a test. You can plug it in at Desmos and take a look. One of the reasons that you have this example is it clear there's 2 vertical asymptotes on this one? See them both? Okay, so one of my vertical asymptotes is right here,
Thank you, Mr. Ray.
and the other one's right here. Okay, and this should make sense. Those are the 2 places where the world can explode. Alright? At 2, this vertical asymptote, if we put a 2 in for x, we would have 2 squared, which is 4. 4 minus 4 in the denominator. 0 in the denominator would make the world explode. We can't touch that spot. Also at negative 2, does it make sense? Negative 2 squared would be negative 2 times negative 2 is positive 4. 4 minus 4 is 0. Can't have that. Okay? So, my vertical asymptotes, you need to have memorized that they are x equals, we got negative 2, and Alex likes to use commas, so negative 2 and positive 2. Horizontal asymptote. Horizontal asymptote's a little bit weird here because this middle section just apparently is like, can go through electric fences no problem. But you can clearly see on the left and right that these are getting closer and closer and closer to the x-axis. So there are still asymptotes there, even though this middle section goes right through it. Okay, so graphs of rationals can be weird, but we do still classify y equals 0 as the horizontal asymptote. Yes, that could definitely happen on Alex or on your test. All right, domain. Let's start with how far to the left does this go? Let me actually, hold on. How far to the left does it go? I hope it's obvious. This is going forever to the left, so that's negative infinity. There's 2 breaks going left to right, though, correct? Because I have 2 vertical asymptotes. So I'm actually going to have 3 parts to my domain. Left part, middle part, right part. Okay, so the left part is negative infinity to negative 2. Does not include negative 2 because it's an asymptote and it will never touch it. Okay? U from negative 2 to positive 2. That's my middle part. Okay? U 2 to positive infinity. So just left to right for my domain. I'm talking negative infinity to negative 2. And then this middle section is negative 2 to positive 2. And then the right section is 2 to positive infinity. Okay, range. And range gets a little bit tricky here also. Don't forget, range is asking. There's infinity coordinate points on these red curves. Okay? So I just need to write down every single y that ever pops up in one of those coordinates. Okay? So on the right and on the left, there's a break, correct? It gets to a point it doesn't cross because there's a horizontal asymptote. But the middle one is still part of this function. The middle one is part of this graph. So clearly it goes down to negative infinity. And my middle one, because it's not afraid of electric fences, covered every single number from negative infinity all the way up to positive infinity. There were no breaks in that middle section. So because the middle part is part of our function, and it touches every single y, then that means we had no breaks. It ranges every single number from negative infinity to positive infinity. Okay, and that one's a little odd, but because that middle section there didn't have any breaks in it, that's why we don't have any breaks in our range. All right, example 3. Okay, I'm going to move a little bit quicker. Vertical asymptote, hopefully you can see pretty easily right here down the middle. Okay, that is at x equals 0. Remember, you have to have that x part memorized. Which makes sense, because if I did 2 times 0 here in the denominator, that would be 0, and the world would explode. Slant asymptote, watch this. There is an asymptote there where both sides of my function are getting closer and closer but not touching. Okay? It's not a horizontal or a vertical line. So if it's not horizontal or vertical, what do equations of lines normally look like? Y equals what? Y, and slope is involved. I heard someone say that. Y equals mx plus b. So we need to write